let's talk about how to add and subtract rational expressions. And I want you to remember that when we add or subtract fractions, there's one really important thing, and that's that we need common denominators. You don't need common denominators to multiply or divide, but you do for adding and subtracting. And the same thing is going to be true for rational expressions. Sorry, guys. Hang on one second. All right, let's keep going. Sorry about that. So we need common denominators. So think about a regular fraction problem. If you had common denominators already, maybe you had 2/3 plus 1/3, then you can just add and keep the denominator, right? 2 plus 1 over 3, that becomes 3 over 3, and then you can simplify, we get just 1 here. Or if you're subtracting, let's say you have 4/5 minus 2/5. Well, 4 minus 2 would go in the numerator and you keep your denominator. So if you have the same denominator, it's pretty straightforward to add or subtract. And the same is true for rational expressions. So for instance, if you had something like 2x over x plus 1 plus 5 over x plus 1, right? I already have the same denominator, so I can just put my numerators together and I keep my denominator. Now, if you can simplify, you would. There's nothing to factor here. I don't see any factors in common, so this would be done. Or if you're subtracting, I'll just use the same denominator. Let's say I had something like x plus 3 over x plus 1 minus 4x plus 5 over x plus 1. Again, you already have that denominator here, so we can just subtract. Now, you do want to be careful when you have subtraction, because that subtraction does have to get distributed to the next expression. So you have x plus 3, and then it's minus 4x and minus 5. So x minus 4x is negative 3x. 3 minus 5 is negative 2 over x plus 1. Nothing to really do here. I suppose I could take a negative out, but it doesn't really help me because I don't have a negative in the denominator to cancel with. So this would be our final result here. And you do want to keep in mind still your domain. So in all of these cases, I have the same denominator. So I have to make sure that x plus 1 is not 0. So you do need to exclude that negative 1 value from your domain here. So in interval notation, negative infinity to negative 1, and then negative 1 to positive infinity. Using those parentheses, we can skip over that negative 1. Or in set notation, we're just going to exclude negative 1 here. All right, so now let's do an example where we don't have common denominators. And I'll start with the fraction one first. So let's say you have 1/5 plus 3/10, and you want to add these fractions together. Well, you need a common denominator. So you want to think about your denominators, think about your factors, and what can you use here? And we could use 10, right? So you want a denominator that you can easily multiply up to. So for 1/5, to get to 10, you'd have to multiply that by 2. 5 times 2 is 10. So we multiplied by the same thing on the top and the bottom. Here, I don't need to do anything. I already have the 10. So my problem becomes 2 over 10 plus 3 over 10, right? Multiplying this first fraction by 2 over 2 so that I can create that same denominator. 2 plus 3 is now 5. And then I can simplify this to 1/2, canceling out any common factors. So you do need to find an LCD here, and you do need to multiply, right, by that missing factor to get to the LCD. And we're going to use the same kind of strategy here. So let's do a couple of examples like this. So here I have 3 over x plus 1 minus 5 over x minus 4. And I definitely have different denominators. So I cannot just go in and just add or subtract these. I have to have common denominators here. So with polynomials, the LCD can be a little trickier, right? Because it's not just a regular number. So what I like to do for my LCD is just combine all possible factors for my denominators. So for this one, this is one factor, right? Think of it like it being stuck together. So x plus 1, I need that denominator. And then x minus 4 is a different one, so I need that one too. So I basically just combined all my different factors together for my denominators. And then what you're going to do is you're going to multiply with whatever is missing. So in the first case, I have the x plus 1, but I'm missing the x minus 4. Oops, x minus 4. And in the second case, I have the x minus 4, but I'm missing the x plus 1. So we are multiplying here by the missing factor, just like we did with fractions. So you want to match that LCD. Now, for your multiplying, leave your denominator in factored form, okay? So you don't have to actually rewrite those answers out there. So leave your denominator in factored form. And we're going to just simplify our numerator. So here, let me rewrite this. I have 3 times x minus 4. I have a minus sign in the middle, and then 5x plus 1. And now your common denominator is just x plus 1, x minus 4. So I'm rewriting it with one denominator, and I'm just kind of, again, rewriting that numerator. And I'm going to clean it up. So this becomes 3x minus 12. Make sure you distribute that minus sign, minus 5x minus 5. (3x minus 5x is minus 2x or negative 2x. Negative 12 minus 5 is negative 17. Now here, if I could simplify further, I would. So the only thing I can factor out of my numerator is a negative sign, which doesn't really help me too much. So I'm going to leave that as my final answer, but you would want to see if you could keep simplifying to cancel any factors in common. And now I'm done. You do have to be careful here with your domains, right? So we have the same factors or same denominators in all cases here. So you need to make sure that x plus 1 is not 0 and x minus 4 is not 0. So we're going to exclude negative 1 and positive 4 here for our domain. All right, let's try another example. All right, so here, 5 over 6x minus 4 over 9x squared. I have another subtraction problem. I do need to have common denominators. So let's take our time and really think about this. Now, if I have numbers, think about your numbers for a second. I have a 6 and a 9. So if it was just 6 and 9, forget about the x's. What would you use? You would have used 18, right? So we're going to use 18 here. And now I have 1x here and I have 2x's here. So I do need to make sure I have all factors included. So because I have more x's here, I'm going to make sure I have those 2 x's included in my LCD. Remember, you're always making the LCD either the same or bigger. You should never be taking things away. So I need to make sure all my factors are included. So is there a 6 included in 18? Yes, right? 6 times 3 is 18. Is there an x included in x squared? Yes, x times x is x squared. So that factor's there too. The 9 is included in 18 because 9 times 2 would be 18. And then the x squared is right there. So you make sure all your parts are included in your LCD. And now you need to multiply by what is missing. So remember, your goal is to get to the 18x squared. So if I have 6 and I want 18, I'm missing a factor of 3. I have an x, but I need an x squared. So I'm missing a factor of x. Here, I have the x squared piece, but I need an 18, so I'm missing a factor of 2. So in the first part, I have 5 times 3x minus 4 times 2. And then my denominator here is just that 18x squared. It's just your LCD. So this becomes 15x minus 8 over 18x squared. Now I would see if I could keep factoring. I really can't do anything here. So this is my final result. Again, watch for your domain. Right, so here I need to make sure that 6x is not equal to 0, and that 9x squared is not equal to 0, and that 18x squared is not equal to 0. But what happens is when you do this is you get all the same results. So here I would divide by 6 and I get x cannot be 0. Here when I divide by 9, I get that x squared cannot be 0. Well, to solve for that, you would take the square root of both sides. Now, normally we take the positive and negative square root, but 0 is not positive or negative, so it's just 0. And then the same thing's going to happen here. You divide by 18, you take the square root, and again, you're excluding 0. So actually, there's only one value I have to exclude here, and that is that value of 0 for my domain. All right, let's do a couple more examples. Let's say I have 4 over x plus 5. So my LCD here. Now, if there is no denominator, you do have one. There's always a factor of 1 there. So putting these two together, I need a factor of x and a factor of 1. So it's just 1x, or x is fine. Now think about what you're missing. So here, I'm not missing anything. I already have the common denominator of x. So this one's fine. But for here, I only have a factor of 1. I don't have the x. So I do need to multiply by x over x there. And I get 4 plus 5 times x all over my LCD. So 4 plus 5x over x. Here, the only real denominator I have is x. So 1, I don't have to worry about being 0 ever. It's just a number. But x can obviously take on different values. So for your domain here, you do need to make sure that x is not 0. All right, and let's do one more. So here we have a harder one. It is adding, and I do see my two denominators. Now, clearly these denominators are not the same, right? They look very different. What you want to do if you don't have clear factors here, so I want you to notice that in our other examples that we did, so in our first example here that we did with rationals that had different denominators, I didn't have any squares. Things were already pre-factored, so I was ready to start right in there. Here, I did have squares, but I had no plus or minuses. So again, I wasn't really factoring there. And even in my last example we just did, very simple denominators. So here we're kicking it up a level. I have a more complicated denominator. So you do want to start by factoring. Always factor those denominators. Again, if you get stuck on rationals, just try factoring and that may jump you in the right direction. So I'm going to rewrite this as having factors first. You don't really have to factor your numerators here. It's just the denominators. So this one is going to factor into x plus 2x minus 1. And then this one's going to factor into x plus 1x minus 1. So now I can see my factors much more clearly, and now I can write my LCD. So you want to make sure all factors are included. So from the first group, I need a factor of an x plus 2, and I need a factor of an x minus 1. From the second group, I need a factor of an x plus 1, and I need a factor of an x minus 1. Well, I already have one x minus 1 here, so I don't need to write it again. If you already have the correct factor included, then you would write it again. The only exception, like we saw, is if you have something squared, well, then I would need to square that factor as well. It's not just the x, it's x squared here. But if it only occurs one single time in each part, then I only need to write it one time. So this is going to be my LCD. So what you're going to do is you're going to take each of your factors there, or each of your expressions, excuse me, and then we're going to multiply by what we're missing. So for the first group here, let's see, I have the x plus 2, I have the x minus 1, but I'm missing the x plus 1. For the second group, I'm missing the x plus 2. So what happens is I have x plus 3, so this would be together, and x plus 1. I'm going to add that to 2 times x plus 2, and the whole thing is over my LCD. Now I am going to keep simplifying now. So you do have a little bit of work for this one. I am going to multiply out my numerator here. So x times x is x squared. X times 1 is 1x. 3x is going to be in my next term. And then 3 times 1 is 3. And then for the second one, I'm distributing that 2. So I have a 2x plus 4. I'm going to keep simplifying. So let's see, I have x squared. And then I have x and 3x and 2x. So that's going to be 4, 5, 6x. And then a 3 plus a 4 is 7. Now, at this point, everything is simplified. You would try to factor the numerator because I do have a square here. So you'd want to try to factor and see if there's anything that you could cancel out. Once in a while, there will be. I would say most times there's probably not, but sometimes there is. If I try factoring this, though, it doesn't actually factor. So if I can't factor it, or if there's no factors in common, then we're going to stop. So this is our final result here. Again, watch your denominators. So if you think about your problem here, I have 3 clear denominators I have to watch out for my domain. So I need to make sure x plus 2 is not 0, x minus 1 is not 0, and x plus 1 is not 0. So x cannot be negative 2, it cannot be positive 1, and it cannot be negative 1 if I solve each of those. And you'd want to see if you missed anything. So if I look at my original denominator here, the factors were x plus 2, x minus 1, and I've already included both of those. If I look at my second denominator, my factors were x plus 1, x minus 1, and I've already included both of those. So if I check my original problem, there's nothing else that I need to exclude. So these are the 3 values. All right, let's do one more of these actually, because I think these can be kind of tough. I'm going to do one more with you guys. Okay, so here I have a subtraction problem. And again, if you see adding or subtracting, you need common denominators. Here, my denominators are much more complicated. I can't just really see the factors, particularly in this first one. So I am going to have to factor here. Okay. So my first part is going to factor as x minus 5, x minus 5. And then here I can take a 2 out, and then I have 2 times x minus 5. So let's figure out our LCD. Now, from my first group, I see x minus 5, and I see another x minus 5. Now, here I have to be careful because my denominator is really x minus 5 squared. So if one of your expressions has that square in it, you do need to include it because you actually have two of that same factor. So you have to include both of them. So it's going to be x minus 5 squared from the first group. And then here I have a 2. I haven't included the 2 yet, so let me bring the 2 in. And I have an x minus 5, but I already have 2 included, so I don't need to bring in a third one. The only time we bring in extras is if you have a square or a cube within one of the original expressions, then that's different. But otherwise, if you already have one listed, I don't need to bring it in again from the second rational expression there. So this is going to be my LCD. So what I'm going to do now is I'm going to take my original problem and multiply by what I'm missing. So for the first group, comparing it to the LCD, I'm missing a factor of 2. And for the second group, I'm missing one of the x minus 5s, right? Because I only have 1, I need to have 2 because it's squared. So here I have x times 2, so just 2x, and then minus, and this one I'm going to be careful, I'm going to write this in, x minus 4, x minus 5. And then the whole thing is over your LCD, which is 2 times x minus 5 squared. Now I do have a bit of work to do here. So I have that 2x minus, and I'm going to just take my time and multiply this out first. Okay. So remember, we do multiplication before subtraction. So I'm going to do the multiplication first. I would have x squared minus 5x minus 4x plus 20. And now I can start distributing that negative to the group. So this gives me 2x minus x squared plus 5x plus 4x minus 20. I'm going to keep cleaning up that numerator here. I get negative x squared. Let's see, 2x, 5x, and 4x is going to give me 11x. And then I have that minus 20 all over my LCD. All right, finally, everything is cleaned up. I would try to factor my numerator. So if I try some different options here, nothing is really going to work. For 20, I'm looking at 1 and 20 and 2 and 10 and 4 and 5. There's no way I can see getting an 11 in the middle there. So I can't factor it. There's nothing else I can do here. And this would be my final results. As you're checking your domain, now obviously from the bottom group here, I don't have to worry about the 2 because 2 is never going to be 0, but I do need to worry about this x minus 5 factor. So I need to make sure that x minus 5 is not equal to 0. I don't need to worry about the square here because this really just means that I have the same factor twice. So for domain purposes, I don't need to do it one time. So I need to make sure I exclude the value of 5 here. Do go back to the beginning though and make sure you haven't missed anything, right? So if I look at my original problem, this one had just x minus 5, which we've already talked about. And this one had just a 2 and x minus 5, which we've already talked about. So the only value we have to exclude here is 5 from my domain. So for these ones here, really take your time. If you have a complicated denominator, you're going to have to factor first to find the LCD. And then just like with regular fractions, you're multiplying by what is missing. And that will allow you to create those common denominators. After that, take your time with simplifying. So these can be a lot of work. The last two were a lot longer than the others because they were a bit more complicated. So just take your time with simplifying, watch out for negatives and things, and you'll be able to get to the right answer.